Scale drawings are also a ratio. Scale drawings are used for things where we might make a miniaturized version. So maybe an architect needs to put up a drawing or a model of what a building is going to look like. You obviously can't make it life size, or you might as well draw the whole building. But you would make a smaller one and you would put the scale and say, this door is only 2 inches tall, but in real life it would be 8 feet tall, something like that. So we've got our scale drawing here. So we're told what our ratio is. So we're told that is 1 to 300. Well, the 1 is going to be the tiny one, and the 300 is going to be the real life one. So the house wall is 4.8 centimeters in the drawing. So this would be my drawing. The small is the drawing, and the real life is the large one. So that would give me 4.8 over x. And then I would do that same cross multiplying that we've been looking at before. So multiplying 4.8 times 300 would give me 1,400. Get my pencil back going. 1,440. Now this is in centimeters. I want to point out, I know it's not a topic that we go over, but this is in centimeters. If it asks for you to do that to meters, there are 100 centimeters in 1 meter. So to convert that to meters, I would divide that by 100 and get 14.4 meters. A lot of times that real life stuff would be in meters instead of centimeters. Centimeters are pretty tiny, so just in case, if we would ask you for centimeters, you could just stop at the 1,440, but if it wanted for meters, which is the more common measurement in real life, then we would divide by 100. It's 100 every single time because there are 100 centimeters in a meter. Now last here are some examples using recipes, and for some reason the recipes really get people, and I think that's because they a lot of time have fractions. So when we have fractions within fractions, it kind of throws people for a little bit of a loop here. So I want to set one of these up. Let's say that 3/4 a package of sugar fills 1/2 cup. So I'm going to set this up, and I know I said we can't leave fractions within fractions. My final answer won't look like this, but for now, I'm going to set it up like this. So that was 3/4 of a package is equal to that many cups. I want to know how many cups, that's my x, are in a full package. A full package is 1. So I'm going to do my cross multiplying. So I get 1/2 equals 3/4 x. Lots of ways to solve this. I'm just going to rewrite it so we can see a step easier. We could divide by 3/4, and we've done that quite a bit where we divide fractions, so you could totally do that and get the right answer. But just to give you another option, you could also multiply by the inverse, by that reciprocal. So I can multiply, I'm going to flip this, 3/4 to give me 4/3. That cancels both of these out. And x, I'm going to reduce it down in just a second. Multiplying is going to give me 4/6, which reduces down to 2/3. Now, since we're dealing with the same information, I'm going to keep my ratio the same for this next one with my package to cup. Now, I want to see if you can set this up and work with those fractions within a fraction. So see if you can set up the other ratio and then solve that proportion. All right, so setting it up, it did ask for 2 cups, so the 2 should go in the bottom, and want to know how many packages. So opposite from what I did up above. I need to do this because, like I said, I like to label these. That way I know where to put what in the numerator and the denominator, where to put my numbers. The packages go with packages and cups go with cups. So I can keep everything even. So I think it's nice to label those out. I would get 1/2 x is equal to 2 times 3/4. Well, 2 times 3/4 is 6/4. You can reduce that down now if you want to, or later, however you might want to do it. I'll do that same reciprocal just so you can see another one. You don't have to. You could divide the fractions as well, but the reciprocal of 1/2 is 2/1. That's going to give me 12/4, which is 3, and this one was packages. So 3 whole packages.